In this video, I'm going to discuss about Poisson distribution. A discrete random variable follows a Poisson distribution if the following conditions are met. First one, an event can occur any number of times in an interval of time or space. The second condition, the average number of occurrences in the given interval is known and unchanged. For example, if the average number of phone calls received is 5 per 30 minutes, which means that at the first minute, the average number is 5. At the second minute, the average number is also 5. At the third minute, the average number is also 5. Then up to the 30th minute, the average number is also 5. And the third condition is the events are independent. This means the occurrence of one event does not influence the occurrence of another. The fourth condition is the probability of occurrence is proportional to the length of the time interval. For example, if one typing error occurs on one page, then 5 typing errors occur on 5 pages, 10 typing errors occur on 10 pages. If a discrete random variable x follows Poisson distribution, then x can be defined as the number of events occur in an interval of time or space. Students, please note that the specified interval can take many forms. For example, it can be a length, it can be an area, it can be a volume, or a period of time. For example, the number of phone calls received on a randomly chosen day. The number of typing errors on a randomly chosen page. The number of daisy flowers on a randomly chosen square meter of a playground. If a discrete random variable x follows Poisson distribution, then the probability distribution is denoted as this way, where P stands for Poisson, lambda is the mean or average number of occurrences in an interval of time or space. The probability of the value of x is this, and for Poisson, x will take on an infinite number. The mean of Poisson distribution is lambda, and the variance is also lambda. Now let's try the first example. The average number of cars which stop at a petrol station is 36 per hour. By assuming that the number of cars which stop at the petrol station follows a Poisson distribution, find the probability that no car stop at the petrol station in a time interval of 10 minutes. In this question, we need to calculate the probability that no car stop at the petrol station. So, the random variable x can be defined as the number of cars stopped at the petrol station, and the interval of time is 10 minutes. Therefore, x follows a Poisson distribution. To calculate the probability, we need to find the average number of occurrence, which is the value of the lambda for the interval of 10 minutes. It is given that the average number of occurrence is 36 per hour, which is 60 minutes. So, when we change the interval from 60 minutes to 10 minutes, the average number of occurrence is 6 per 10 minutes. Therefore, X follows Poisson distribution with the lambda is 6. The probability that no car stop at the petrol station means the probability of X equals 0. When we substitute the value of lambda and the value of X in the Poisson formula, the answer is 0.002479. Question B. Find the probability that more than 3 cars stop at the petrol station in an interval of 10 minutes. In this question, the interval of time is still the same, so we could use the same distribution to find the probability. The probability that more than 3 cars stop at the petrol station means the probability of X greater than 3. Since in Poisson distribution, the possible values of X is infinite, so X greater than 3 must be changed to 1 minus the probability X less than or equal to 3. When we substitute the values into the Poisson formula, then the answer is 0.8488. Question C. Find the probability that more than 5 cars stop at the petrol station in an interval of 20 minutes. In this question, it is found that the time interval has changed to 20 minutes. If the time interval change, then the value of lambda also change. In the interval of 20 minutes, the average number of cars is 12, which means that the value of lambda is 12. Since the value of lambda is different from the variable X, so the different variable should be created. Let's say the variable Y. So, Y represents the number of cars stopped at the petrol station in a time interval of 20 minutes. And Y follows Poisson distribution with lambda equals 12. The probability that more than 5 cars stop at the petrol station means the probability Y greater than 5. This is equal to 1 minus the probability of Y less than or equal to 5. Using the Poisson formula, we got the answer as 0.9797. Question D. Find the probability that less than 2 cars stop at the petrol station in an interval of 5 minutes. In this question, it is found that the time interval has changed to 5 minutes. In the interval of 5 minutes, the average number of cars is 3, which means the value of lambda is 3. Since the value of lambda is different from the variable X and Y, so another variable should be created. Let's say the variable W. So, W represents the number of cars stopped at the petrol station in a time interval of 5 minutes. And W follows Poisson distribution with lambda equals 3. The probability that less than 2 cars stop at the petrol station means the probability of W less than 2. Using the Poisson formula, we got the answer as 0.1991. Next example, in a publishing company, typing errors are found on the pages of the draft of a book. On average, 2.5 typing errors are found per 100 pages. If a page contains one or more errors, it will be sent for correction. Find the probability that a page will be sent for correction. In this question, we are going to calculate the probability that a page will be sent for correction. But in this case, the random variable shouldn't be defined as the number of pages sent for correction. If so, then we don't see any interval of time or space. From the question, we found that if a page contains one or more errors, then it will be sent for correction. Therefore, the variable could be defined as the number of typing errors in a page. Next, I'm going to find the value of lambda for the interval of one page. It is given that the average number of errors is 2.5 per 100 pages. So, when we change the interval from 100 pages to one page, the average number of errors is 0.025. Therefore, X follows Poisson distribution with the value of lambda is 0.025. The probability that a page sent for correction means the probability of X greater than or equal to 1. This is same as 1 minus the probability of X equals 0. When we substitute the value of lambda and the value of X in the Poisson formula, the answer is 0.02469. Question B. Find the probability that 2 out of 3 pages will be sent for correction. In this question, we are going to find the probability that 2 pages out of 3 pages, which means that the random variable can be defined as the number of pages. Sent for correction is considered as success criteria, and the number of pages is part of the 3 pages here. Therefore, the variable follows binomial distribution with n is 3 and the probability of success is the probability of a page sent for correction, which can be taken from question A. The probability of 2 out of 3 pages means the probability y equals 2. Using the binomial formula, then we got the answer as 0.001784. There is another way to solve this question. 2 out of 3 pages sent for correction means the first page is sent for correction. Sent for correction means the number of error is more than or equal to 1. And the second page is also sent for correction. And the third page is not sent for correction. Not sent for correction means the number of error is 0. Or the result could be in different arrangement where the first page is sent for correction and the second page is not sent for correction and the third page is sent for correction. Or the third option of arrangement, where the first page is not sent for correction, and the second and the third page are sent for correction. The probability of x greater than 1 could be taken from the question A. The probability of x equals 0 could be found by using the Poisson formula. Since there are 3 options, then times 3. After calculated, the answer is equal to 0.001784. Next example, at a housing area, dengue fever cases occur at an average of 1 in every 5 days. Find the probability that at least 1 dengue fever case occurs in a period of 1 week. To find the probability, we need to define the variable. For this question, since the question asks at least 1, so the variable x can be defined as the number of dengue fever cases in a period of 1 week. For this question, we know that the average number of cases is 1 in every 5 days, where the interval of time is 5 days. So we must change the interval to 1 week, which is 7 days. So every 7 days, the average number of cases is 7 over 5. Therefore, the distribution of x is a Poisson distribution with lambda is equal to 7 over 5. The probability of at least 1 dengue fever case means the probability of x greater than or equal to 1. This is same as 1 minus the probability that x equals 0. Then we substitute the values into the Poisson formula. We got the answer 0.7534. Question B. Find the probability that in a period of 6 weeks, no dengue fever cases occur on at most 3 of the 6 weeks. First, we try to define the variable in order to determine the probability distribution such that we can find the probability. From the information, when we first see in a period of 6 weeks, students might think that this is a Poisson distribution because there is an interval of time. Then the variable might be defined as the number of dengue fever cases occur in a period of 6 weeks. If this is the case, then where to define at most 3 of the 6 weeks? Now, let me put it in the other way. We define y as the number of weeks because we are going to find the probability that at most 3 weeks out of the 6 weeks. The observations are weeks. The weeks with no dengue fever cases occur are considered as success. Therefore, y follows binomial distribution with n is 6 and the probability of success is the probability that a week which has no dengue fever cases occur. This probability can be calculated by using the probability distribution x because x is defined as the number of dengue fever cases occur in a week in question A. Since x follows Poisson distribution, by using the formula of Poisson distribution, probability of x equals 0 is equal to 0.2467. 6. Once we have got the probability distribution of y, then we can find the probability of at most 3, which is the probability of y less than or equal to 3, and by using the binomial formula, the answer is 0.9642.